In this video, I will show you how to evaluate and graph a piecewise function. When you want to evaluate a piecewise function, the first thing you have to do is decide which piece of the function you're supposed to use. So this part of the piecewise function, the domain, tells us when to use which part. So we will use the first piece whenever the x values are less than or equal to 1. We will use the second piece whenever the x values are greater than 1. So let's start with 0. Is that less than or equal to 1, or is it greater than 1? Obviously 0 is less than 1. So that tells us we will use the first piece. So we will use the 3 minus x. So this will become 3 minus 0, which is just 3. So the answer is 3. What about the value 1, the x value of 1? Well, 1 is equal to itself. So we will use the top function for x values that are less than or equal to 1. So this equals 1, so we use the top function again. So 3 minus x becomes 3 minus 1, which is 2. So the answer here is 2. Now finally, 2.5. 2.5 is greater than 1. That tells us that we're going to use the second piece. So the second piece says we do 2 times x. So that's going to be 2 times 2.5, which is 5. So the answer to this part is 5. Okay, take a look at problem number 2. Again, we first must decide which piece we're going to use. Okay, and maybe I'll color code this. So we'll have the blue piece, and we'll have the red piece, and we'll have the green piece. Okay, this area tells us when to use which piece. We'll use the blue piece for x values that are less than 1. We'll use the red piece for x values that are between 1 and 3, including 1 and 3. And we'll use the green piece for x values that are greater than 3. So where does 0.5 fit into this system? 0.5 is less than 1, so we will use the blue piece. Okay, so I think I will just do the work in random places. So 0.5. So if I do 4 minus x squared, for 0.5, that is 4 minus 0.5 squared. So that's 4 minus 0.25, which is 3.75. So this answer is 3.75. Okay, what about an x value of 1? Well, we will use the red function whenever the x values are between 1 and 3, including 1. Okay, see the or equal to part? So that tells us we will use this function whenever it equals 1. So we use the red function. So this will become 3 over 2 times 1 plus 3 over 2. So really that's just 3 over 2 plus 3 over 2. So that is going to be 6 over 2, which equals 3. So that's the answer for that one. Okay, what about the number 3, an x value of 3? Again, if x is less than or equal to 3, we use the red function. Okay, so it's equal, this is equal to 3, so we use the red function. So let's see, I'm going to squeeze it in up here. So this will be 3 over 2 times 3 plus 3 over 2. Now remember, this is like 3 over 1. So this is going to make 9 over 2 plus 3 over 2, which equals 12 over 2, which equals 6. All right, what about an x value of 4? Well, we will use the green function, because we use the green function whenever the x value is greater than 3, which 4 is. So we're going to use the green function. So x plus 3 becomes 4 plus 3, which is 7. So that's it for problem number 2. For problem number 3, we need to graph this piecewise function and state the domain and range. Now, the first piece is a line. The second piece is also a line. So our graph will end up being a piece of this line and a piece of this line. So think of this in terms of endpoints. So I'm going to graph this function in blue, and I'm going to graph this function in red. Now, this value right here tells us where we begin using this function. So this value is going to help us find the endpoint of this part of the graph. So we are basically being told the x value of the endpoint right here. So the endpoint is going to be 1 comma something. I need the y value that goes with this, though. So think of this as y equals x minus 3. If x is 1, then that would become y is equal to 1 minus 3, which is equal to negative 2. So the endpoint of this piece of the graph will be the point 1 comma negative 2. Notice that we're going to use this function for x values that are less than or equal to 1. So that's important because I'm going to graph this as a closed circle to show that this point is included in the function. Okay, so 1 comma negative 2 would be right here. And we will make it a closed circle because of the or equal to. So now let's graph the rest of the function. So this is a line, and I know that this is a point on the line. It's the end point of the piece of the line that we're going to graph. This function applies when x values are less than or equal to 1. So you should be thinking to yourself, we're going to be going to the left, because that's where x values are less than 1, to the left. Okay? Now, however, think about the slope. Remember y equals mx plus b? So this line, y is equal to x minus 3. The slope is 1. So it's like 1 over 1. So if I were going to the right, from this point I would go up 1 over 1, like this. But I don't want the points that are going to the right. I want the points that are going to the left. So if I go to the left, I will go down 1 over 1. I'm just sort of repeating this pattern backwards. Down 1, left 1. So these points will be going like this. Okay, so this is the first piece of my piecewise function. All right, I'm just going to erase those little points that I drew as I was explaining the problem. So we're finished with the first piece. We have now graphed the first piece. So now we need to graph the second piece. So again, this value is going to give us the endpoint for this piece of the graph. So the x value is still 1. What's the y value going to be now? So remember, this is like y equals 2x. If x is 1, that means y is equal to 2 times 1, which is equal to 2. So the endpoint of this piece of the function is the point 1 comma 2. This will be an open circle because we only want values that are greater than 1, not equal to 1. So this point is not to be included, but it still counts as the endpoint. We'll just make it an open circle to show that it's not included. So 1, 2, and open circle, please. This piece applies when x values are greater than 1. So you should be thinking to the right of 1. This was to the left, this is to the right. So this piece of the graph we will graph to the right. Now, 2x. Think of y equals 2x. 2 is the slope. That's 2 over 1, rise over run. So starting from this point, I would go up 2 and right 1, like this. So this is what this piece of the graph is going to look like. And that's it. That's what this piecewise function looks like. Now we need to say the domain and the range. All right, now the domain is actually going to be negative infinity to positive infinity. We do not give 2 separate domains for each piece unless there is a break in the domain. Now, looking at the x values, there is no break. Think about it. If I were to ask you for just the domain of the blue part of the graph, the blue part of the graph goes from negative infinity to 1. Okay, that's the blue domain. If I were to ask you for the domain of the red part of the graph goes from 1 to infinity. Put those together, and the domain goes from negative infinity to positive infinity. There is no break in the x value. There's no break in the domain. Okay, so we do not have to write it as 2 separate parts, and you must not write it as 2 separate parts. So the domain is simply going to be negative infinity to positive infinity. Now let's do the same thing with the range. The range is the y values. Okay, so for example, if I were to ask you for the range of the blue part, which we can trace on the y-axis, the range for the blue part of the graph would look like this. Okay. The range for the red part of the graph would look like this. Okay, it's the y value. So on the y-axis, this portion of the graph starts here and it goes up. See how there's a break in the range? That's why when we write the range, we will have to do it in 2 separate parts. So for the blue part of the graph, this goes from negative infinity to 2. Okay, with a bracket because this is included. Okay, so for the range, we will say negative infinity to 2, bracket. And when there are more than one portion to the domain or the range, we will use the union symbol. The second part of the range goes from 2 to infinity. We'll use parentheses this time because this point is not included. So union 2 to infinity. The order is important. You always want to do the range from least to greatest. So from bottom to top. Now, points of discontinuity. We are talking about where the graph jumps from one value to another. So what is the x value of this break in the graph? All right, this gap. The x value is 1. So we will say that there is a discontinuity at x equals 1. So you can think of points of discontinuity as the x values of the break. All right, a discontinuity is just a break in the graph. Let's do the same thing for problem number 4. Let's graph it and state the domain and range. This has three parts to it, so I'm going to use three colors. So this will be the blue part, this will be the red part, and this will be the green part. Okay, so I'm going to graph these one piece at a time. Let's start with the blue piece. This value right here is going to help me find the end point of this piece of the graph. So this is an x value, so -2, comma something. Now I just need the y value of this endpoint. Well, guess what? This is a tiny little equation. Think of this as y equals 2. When you have a constant like this, just y equals a number, it's just telling you what the y value will always be. So it's telling us that the y value is automatically 2. So this is the endpoint for this piece of the graph. We will make it an open circle because this is not going to be included because it doesn't say or equal to. So -2, comma 2, and open circle. This is the endpoint of this piece of the graph. Now, y equals 2 is a horizontal line at 2. This less than tells us that we want the points that are to the left of this point. Okay, so horizontal line at 2, but we want the part of the graph that goes to the left. So there you go. That's the blue piece of the graph. All right, now let's do the red piece of the graph. Okay. Oh, wait. For a minute there, I thought this -2 was part of the function. It is not. The function is just right here. This is the domain. So this domain has two endpoints. Okay, it has an endpoint at -2, comma something. And it has another endpoint at 3, comma something. So this is going to be a segment. So I need the y values of these endpoints. So remember, this is like y equals -2x. So I think I'll just squeeze this in. I'll put it over here. So if I have y equals -2x, if I substitute in -2, then that's y equals -2 times -2. That's y equals 4. So that's one endpoint. Now, if I substitute in 3, so y equals -2x, that's y equals -2 times 3. That's y equals -6. So that's -6. So these are the endpoints. They will both be closed circles because of the or equal to. So -2, comma 4, closed circle. 3, comma -6, closed circle. Okay, and y equals -2x is a line that's linear. So I know it's just going to be a straight line, but look, just to help me draw it more easily, the slope is -2, meaning down to right 1. So I could think of it that way. I could sort of step my way down to right 1. That'll give me some guide points. Okay, so now I could just draw the segment. So that is the red piece of the function. So now it's time to graph the green piece of the function. Again, this number in the domain tells me the endpoint. It leads me to the endpoint of this piece of the function. So this is the x value. I still need the y value. So remember, this is y equals this. Okay, so I think I can squeeze it in right here. So I've got y equals 2 minus x squared. So if x is 3, this becomes y equals 2 minus 3 squared. That's y equals 2 minus 9. Y equals -7. So negative 7. There was a little mistake in there. A minute ago, this had an or equal to sign under it, but the previous piece said we are supposed to use this piece when x equals 3. So it can't now say we're going to use this piece when x equals 3. So I went ahead and changed this to greater than 3, which means that this will be an open circle. So 3 comma negative 7, open circle. Now graphing this will be tricky. When you see this greater than 3, you should be thinking to the right of 3. So yeah, we're graphing to the right. However, this is a parabola. So it's a little bit trickier to graph than a line. So I would recommend a table of values. Okay, x and y. Starting with 3, we already did that one, so that was 3 comma negative 7. Now we want values to the right of 3, so we're going to do like 4, 5, 6, 7. Okay, so what will this be? So remember that we're dealing with y equals 2 minus x squared. Okay, so in this case, it's going to be 2 minus 4 squared. That's 2 minus 16. So that's going to be negative 14. Okay, that seems like it's already off the graph. Let's keep going and see how it goes. All right, so this one would be 2 minus 5 squared. Okay, so that's going to be 2 minus 25, so that's going to be negative 23. So this is just getting worse and worse. Okay, so I had 3 comma negative 7, but then I have 4 comma negative 14. I think that's as far as I'm going to be able to go. Okay, because this is already going to take me way off the graph. All right, so 4 comma negative 14, I already have to estimate. Okay, so let's just say it's like down here somewhere. This is a downward facing parabola. This is not the vertex though, so don't just try to like go straight there, but this is not a line, so I am going to just make it a little curvy. Okay, I failed at that. All right, it's just a very slight curve, and there's no way to really be precise about this, but okay, something like that is the best you can do. If we had more space, I would have plotted more points, and sometimes it's more obvious that this is a curve and not a straight line. Anyway, let's do the domain and range. Once again, the domain is going to be negative infinity to positive infinity. All right, every x value is covered from left to right without any breaks. Looking at the domain of the blue part of the graph, the blue piece goes from here to here. The domain of the red piece, on the x-axis, it goes from negative 2 to 3. And then the domain of the green piece will go from 3 to infinity. So put them all together, and you have negative infinity to positive infinity with no breaks. So that's the domain. Okay, now what about the range? Okay, so the range of the blue part of the graph, on the y-axis, this would actually just be a single number, 2. That's the range of the blue part of the graph. Now, the range of the red piece of the graph, okay, what are the y values of this? If I trace it out on the y-axis, it goes, the red part of the graph goes from negative 6 to 4, all right, which overlaps with the previous point, so that's fine. Okay, just just keep up. So far we have this, -6 to 4. I kind of made that a little too high. Let me be slightly more careful than that. So let me try that one more time. Okay, now the range of the green part is going to go from -infinity up to -7. All right, so this yellow shows what the range will be. So notice that we have a gap in the range. So we will have to do the range in two separate pieces. Okay, so the range goes from -infinity to -7, open circle, because this is an open circle. So parentheses, because we had an open circle, and then union, and then the second piece of the range goes from -6 to 4. All right, close circle, so bracket, bracket, -6 to 4. Okay, so that's the domain and range. Now remember, points of discontinuity are the x values of the gaps in the graph. Okay, discontinuities are breaks or gaps in the graph, jumps. So we have a discontinuity right here. The x value is -2. Okay, so we have one point of discontinuity is x equals -2. We have another break, another gap right here. The x value of that is 3. Okay, so that point of discontinuity is x equals 3. So that is it for problem number 4. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.